Hello everyone, very good morning to all of you. In Object-Oriented Programming 1, today we will start with Unit 9, that is Binary I/O, Recursion and Generics. We will use the reference book Introduction to Java Programming by Y. Daniel Liang. So we'll cover today Text I/O and Binary I/O. Second, binary I/O classes. Third, object I/O, and at the last, random access file. So starts with text I/O and binary I/O. Now the first question is that why we need file handling. So the file handling we are using because we want to store all our useful data somewhere permanently, which you use to run a program, and whatsoever the input you are giving, that will not be stored anywhere. Whatsoever the output is there on your screen, once you will finish the program, you will close the file, that data will be lost. It means that your input and output both are not stored anywhere if you are not using file handling. So whatsoever the file that we want to create and where we want to store it, that is your text I/O, which we have already seen. In this unit, we will see what is binary I/O. I/O means input and output. So generally the files can be classified as either text or binary. A file that can be processed, we can read the file, create the file, modify it, that is using a text editor such as a Notepad, then this is called a text file. For example, if you are having a Java file, any of the .java file, which you are opening with a text editor like Notepad, then it is in a human readable form. We are writing the content as the English kind of statement. Have you ever tried to open a .class file with Notepad? If you have tried, then you must know that the content is not in readable form, because whatsoever the file .class file that you are opening with Notepad, it will be open, but it is not in readable form. Such kind of files are known as binary files. You cannot read the binary files using a text editor, and they are designed to be read by the programs. An example of Java, your class file will be read by your JVM. So Java provides many classes for performing text I/O and binary I/O. We'll see one by one. Now, a text file is actually what? It is a sequence of characters. And what is binary file? That is sequence of bits. For example, a decimal integer 199, that is stored as a sequence of 3 different characters, 1, 9 and 9. That is in text file. But the same integer is stored as a byte type value, that is C7 in your binary file, because the decimal 199 equals to hexadecimal C7. You already know any of the decimal will be converted into a hexadecimal by dividing that number with 16. So you know that it will be C7. That is the answer. So in a binary file, it will be stored as a C7, not as 199. So the advantage of this binary file is what? It is that they are more efficient to process than the text files. Java offers many classes for performing file input and output. This can be categorized as a text I/O classes and binary I/O classes. Text I/O. The text data are read using a scanner class and writing or written using a print writer class. This example we have already seen in a previous unit. But before starting with binary IO, you need to understand or recall the concept of text IO, an input class that contains methods to read the data and the output class that contains the methods to write the data. So here input class is your scanner class and your output class is your print writer class. Generally, if you are not using the file handling, you are using the console input output. Now what do you mean by console input output? Console input means your default input. So that is your keyboard, and your console output is generally your monitor screen where you use to write your data so user can see that. Like if you want to print on your screen, welcome to Java, you're supposed to write that inside system.out.println. So whatsoever you are writing in between the system.out.println double quotation, that will be printed on your monitor. So this till date you are using this console input and console output for scanning your data as well as printing your data. But now we are using file handling, so for that we are using a scanner class, but we will not take as a system.in. We will not read our data from keyboard. Instead of that, we will read our data from a file. And we are not printing our data on monitor. Instead of that, we are printing our data into a file, means we are writing into a file. Now what is the main difference between text IO and binary IO? Binary IO does not involve any encoding or decoding, and thus it is more efficient than any of the text IO. By default, all the files which are stored in a computer, that is in binary format. You already know the example of high level language and low level language. Why we are using high level language? Because it's convenient for the user to write any of the syntax in English kind of statement. That is why we are writing our Java program in particular syntax and semantics. But ultimately this .java file, whenever we are storing on a disk, it will be in a binary format only. So that is your binary file. So encoding and decoding are automatically performed for the text IO. Any of the file that we are storing on disk, that will be automatically converted into the binary IO. If we are talking about Java, then JVM will perform this task to convert this Java file, that is a text file, text IO, that will be converted into binary IO. So we'll see the same example, that if we want to write this 199 into any of the binary file, binary IO program, then this 199 will be converted into a hex code which is C7, and this will be written same byte as in a file in binary IO. But when we are talking about a text IO program, then the Unicode of the character will be there in your disk. So you already know in Java we are using Unicode. Unicode is of 2 bytes. In this, each and every character and digits, they've pre-assigned Unicode. So here the character 1, a digit 1, that is having a Unicode, that 0x31, that is the hexadecimal code. For 9, it is pre-assigned, that 0x39. Again there is a 9, then 0x39. So how this bits are stored actually in text IO and it is actually stored in binary IO because Java is using Unicode. If we talk about the Ascii code, it would be more clear to you that your digit 0 will have Ascii something, that is 48. So here if we will talk about the Ascii code, then 1 is stored as 49 because Ascii code starts from 48 for digit 0. Same way, if we are having a digit 9, then it will be stored as 57, right? So same way where we are using Ascii code, same way we are having a Unicode for particular characters and digits. We have already seen why the binary IO is more efficient than text IO, because binary IO does not require any kind of conversion. So no encoding and decoding scheme is there in binary IO. Binary files are independent of encoding scheme on the host machine and thus they are the portable. So Java programs on any machine can read a binary file created by a Java program. This is why the Java class files are the binary files, and the Java class files can run on any of the JVM on any of the machine without any dependency on OS. So before starting binary IO classes, let's have a look of text IO, that how we are writing any of the data to a text IO. So here we are having one class that is write data. In that I've created an instance of file, that is file equals to new file named as scores.txt. Now if the file dot exist means you are already having a file with the same name, then it will show you the message that file already exists and it will simply exit from the system. And if it is not like that, that scores.txt such kind of file has not yet been created, then we will continue with the code. We are creating one class object, that is print writer output. So output is actually the object of print writer class, where we are just passing a file instance which we have already created with the file name scores.txt. Now we are simply writing into a file, and here we are using the same methods like print, println, printf. These all the methods that we have already used with system.out. But the difference is that here we are not writing system.out.print. If we will do it, then this text will be simply shown to your monitor. But what we want to do is, we just want to write this content into your file. So you are already having your instance of print writer class, and we are using that object output.print, and we are giving some string. So this will be written to your file. Same way I am writing also the score for it. Again I am writing another data and a score, and finally I am closing output with output.close. Now let's run this code. This write data.java. I'm compiling this program. And simply I'll run this code. But before running this code, just let me show you the folder that OOP1 programs. Here I don't have any scores.txt file, right? But when I'll run this code, This code has been run and nothing is shown here. Why? Because we have just written to a file, but we haven't shown this on your monitor screen. So now just look at this folder. Here we are having this course.txt file. When I'll open, this is my data. Now we will see how to read this data. So for that, I'm having another file which is having a class name read data, and in this I just want to create a file instance, and which file I want to read, that is course.txt. Now I'm creating object of scanner class, but we used to write over here system.in when we want to take the data from keyboard from user. But here I'll not use system.in. Instead of that, I'm passing the instance of file because I want to read the data from course.txt, right? So to read the data, it will read till it is having a data. So for that, we are having a hasNext method. So I'm calling this method with the use of object input. So input.hasNext, next, whenever it is true, this code will run, right? So here I'm having first name, I'm having middle name, I'm having last name, I'm having score in a single line. So this 4 data I'm taking, and finally I'm printing this and simply input.close. Now I'm compiling this code, read data.java, and I'm running this file java read data. What it is showing, whatsoever the data is there in course.txt file. So this was all about your text IO. Now we'll continue with binary IO classes. So for binary IO, we have some inbuilt classes like input stream, output stream. These are your parent classes, and as a child class, file input stream, filter input stream, object input stream. Again, filter input stream is having 2 child, that data input stream, buffered input stream. Same way, it's having data output stream and buffered output stream. So this is actually the hierarchy where data input stream inherited from filter input stream, and this filter input stream inherited from the input stream. So ultimately, this all the classes will have all the characteristics or methods of input stream and output stream class. So the abstract input stream is a root class for reading binary data, and the abstract output stream is a root class for writing the binary data. So ultimately we want to read and write our data in binary IO. Now in input stream class, we are having lot many methods like read the array of the byte, read the array of the byte with the offset and the length, then available method, close method, skip method, mark supported method, mark the current position, so we can give the integer as an argument. Then we are having reset, which will reposition the stream at the beginning of your file. So these are the methods that we will use again in a programming, so it would be more clear. Then we are having output stream class, where we are having the methods which is useful to write your data. So we are having write method, we are having write array of the bytes, we are writing from a particular position, we are closing our file, and we'll use the flush. Flush will simply empty your output stream and forcibly write all the data onto your monitor screen, or it will be in your file. So here the first class, that is file input stream and file output stream, in that all the methods in these classes are inherited from input stream and output stream. So no special methods are there in your file input stream and output stream, because this class is inherited from input stream and output stream. So it can already use all the methods of those two classes. So here we are having only two constructors, where in one you are passing directly file instance, and in second you are giving a file name as a string. So here when you are giving a file name and it does not exist, at that time the file not found exception will be raised. Now where we are writing into a file does not exist, a new file will be created. If the file already exists, then the first two constructor will delete the current content of the file. You can see that here in first two constructors, if we are giving a file name over here and that file is already exist, then it will overwrite it. It will not ask you that you want to replace or you want to overwrite that file. If we will write a code in such a way, then this thing is possible. In other two constructors, what we are doing is we want to keep our original file as it is, and the new content will be appended in the same file. So for that we are having another two constructor where you can add one more parameter, that is boolean append, means true or false. If you want to make it true, at that time the current content, it will append a new data into a file and it will not overwrite your existing file. So now see the example of file input stream and output stream. Here we are having one class, that is test file stream, where in this try we are just creating instance of file output stream. Instance name is output equals to new file output stream named as temp.date file. Here now we are writing into that file. We have just taken a for loop which will run from 1 to 10, and we are writing output.write, that's I. So first time it will be written as 1, next time 2, 3 till 10. So 1 to 10 is there in our file after running this code. Now once I have written this data to my file, I need to read the same data from the same file. So for that, again in this try, I have created instance of file input stream. Instance name is input, and which file we want to read, that is temp.date. So now when I have taken as integer value, why I have taken it? Because if it is equals to -1, means it is reached to end of the file, means now I don't have any data to read. So this loop will continue till I am having a data, and to read the data I am having a method simply read with the instance input, and when the value is equals to -1, this loop will discontinue. What I need to do in this reading of the data, I simply want to print that data onto my monitor screen. So I've used here system.out.print, and I just want to print the value, because ultimately whatsoever you are reading, that will be in this value. But when it will reach to -1 means end of the file, I'll simply exit this loop. Now I'll simply run this code, and you can see that the output is 1 to 10 because I've used over here print, not print ln, right? So whatsoever we have written into a file, that we read it out from the file. Okay. Now the next class is data input stream and data output stream. Here in data input stream, that will read the bytes from the stream and convert them into the appropriate primitive type values or strings, because it is not necessarily be like that our data would be in string only. Our data can be in byte, our data can be in boolean, it would be in float, double. So we need to read the various kind of data from the file. So here we are having a data input stream class to read such kind of primitive type values. Same way I'm having data output stream which will convert the primitive type values or a string into the bytes and output the bytes to the string. So here in this class we are having lot many methods to read the data, read boolean, read byte, read character, float, and so on. The last is read UTF. UTF is again a kind of encoding decoding scheme which we have already seen at the time of Unicode. So if I'm saying that it's a UTF-8 format, then it will read 8 bit of data. If I'm saying that UTF-16 means it will read 16 bit of data. So such a way we are having a different UTF format. So to read that data, I'm having read UTF. So you can see in the figure, here we are having one file which I want to read, then it would be there in file input stream where I'll be having my data into binary form, and finally I'm having this data in a suitable form, that is maybe it's integer, it's double, float, any kind of data. Same way I'm having my integer, double or string kind of data that I'm writing as in a file, then the file input stream, it would be having a binary data. So a data input stream and data output stream read and write a Java primitive type values and string in machine independent fashion, thereby enabling you to write a data file on one machine and you are reading the same data from the another machine, whether they are having a different operating system, a different file structure, then also it will not affect. So let's have example of this data input stream and data output stream. Here I am having one class that is test data stream. In that this try block, I have instance output of a class data output stream because I want to write some data first and then I will read the data. So here you have just passed a file output stream, and inside that I'm having temp.dat file. As you have already seen in figure that whatsoever my data output stream, I'm having my integer, float or string kind of data that I'm sending to file output stream, and then finally whatsoever my file name is there, that will be stored on my hard disk. So here I'm having a temp.dat file and I'm writing here with write UTF, that is a method where I'm writing my string. Here with the write double method, I'm writing my double data. Here with again write UTF, I'm having another person's name. Again I'm writing a score with write double, and here I'm having a score, same way for all. Now I'm reading the same data whatsoever you have written with the use of data input stream. Here I'm again creating an instance of new file input stream, and I want to read my data from temp.date file. Now I'm just reading the data, and meanwhile I'm showing this data on monitor with the use of system.out.println method. Here I'm reading one by one all the data. If I have written my data in this UTF format with the use of write UTF, same way I am reading my data with read UTF. Then secondly, my data is read double, which I have written with write double. That is my score. Same way I am reading my second data and third data. Right? Now we will compile and run this code, but before running this code I would like to show you that we don't have any temp.dat file, right? But after running this code, it will be a temp file over here. When I'll try to open this file with Notepad, it will show me some such kind of symbols. Why? Because this is your binary file and it is not readable with any of the text editor, right? So here you can see whatsoever we have written into our file, the same data we are reading and showing onto a monitor, right? Again back to the class. Now the next class is buffered input stream and buffered output stream. Basically we are using these classes because we want to speed up our execution. This buffered input and output stream can be used to speed up input and output by reducing the number of disk read and write. You can see in the figure, when we want to write any of the data through this buffered input stream, it will store first of all into this buffer. For example, we are writing 100 of the lines over here. It will be there into a buffered input stream. It will not write directly into your file. Once I'll finish with my writing, at the same time it will directly flush to my actual file with all the 100 lines at the same time. If I'll not use this, then each and every time whenever I am writing a code to write a single line, it will go and write it. Again it will come back, it will go and write it. So it will simply reduce the overhead of your disk read and write. Same way for reading. Now the next is object IO. Object IO is object input stream and object output stream, where I simply write and read any of the primitive values as well as objects also. So I can read and write object too. So here I can read the object with this method and I can write the object with write object method. Now before this object IO, first we will see one code where we have used buffer input stream and buffer output stream. So this is basically a program of copy a file. So simply for that we have used command line argument. So when we are running this code, at that time only we have to specify two files One is your source file and the another one is your target file. That which file you want to copy into which file. So for that, first I am checking that the argument length is 2 or not. Means I have specified my source file as well as target file or not. So if it is not specified, at that time it will simply show you the format that Java, then the file name copy, then you have to give source file and you have to give the target file. This should be the format and it will simply exit. Now here we are creating instance of a source file with argument of 0 because we don't have name right now. Otherwise, till date, what we used to do here in double quotation, we are giving the names course.txt. For example, source.txt I want to copy into course1.txt such a way. But here we don't want to do this because I don't have the name predefined. So simply over here we will write args of 1 and here it would be args of 0. Right? So here I'll get my source file, and if the source file does not exist, at that time it will simply show you the message that from which file you want to copy, actually that file does not exist. Right? Secondly, you want to copy in your target file, and if the target file name already exists, then at that time you have to check this condition. If your target file already exists, then you don't want to overwrite and simply you will exit. So you are just simply showing this message that this file is already exist, please give some another name, and it will simply exit. Now what we are doing, now we are actually implementing the code of copy. So here we have used buffered input stream, instance name is input. You already know buffered input stream again use the file input stream, and then it will be your source file at this place. Same way for the output stream, you are creating the instance of file output stream and you are passing as an argument your target file. So here we are continuously reading a byte from the input and we are writing it to the output. So for reading that integer data, I am having this r equals to input dot read. So it will read the data till it will reach to end of the file, means -1. Once I have read the data, what I need to do, I want to write it into my output file, means my target file. So I am writing with output dot write, and what I need to write, that r, which I have read from this input, right? And I just want to increment that number of bytes has been copied. So for that I have taken this variable initialized with 0 and I'm just increasing this every time whenever it's writing into another file. So finally I'll get that how many bytes are copied, right? And to show this, I've used system.out.println that this many number of bytes are copied. Fine. So now we are running this code, and as you know, to run this code, I've used command line argument. So at the time of running, I need to give this Java, then a file name, then source file, and my target file. So here Java copy, and which file I need to copy, that I have to write. So for example, if I want to copy this write data.java, and I'll give the name as temp11.java. Before running this code, I would like to show you this folder where the temp11.java does not exist, right? So after running this code, once I'll enter 472 bytes copied, and here I'll have this temp11 java file, which is same as your write data file. Simple. So now again, continue with our object IO. Here this object IO, we have seen object input output stream classes can be used to read and write serializable objects. So now what do you mean by serializable? A serializable object is an instance of java.io.serializable interface. So the objects class must implement a serializable interface. Here the serializable interface is a marker interface. You already know what is marker interface. You have seen this at the time of clonable interface, where marker interface does not contain any of the method. So compulsorily we don't have to include that method into my class when I'm implementing serializable interface. Since it has no methods, you don't need to add any additional code in your class that will implement serializable. So Java provides a built-in mechanism to automate the process of writing the objects, and this process is referred as object serialization, which is implemented in object output stream. Now the question is that when the serialization is required. So for example, you know array list. Array list is actually a list of different kind of objects. So here you are having a list of one kind of class object, you are having another kind of class object. So at that time when you are writing the array of integer, you are writing the array of double. So at that time it will create a space at a different memory location. So I just need a serialization so that each and every list, each and every kind of class object, I'll get it in a single file, right? So at that time this object serialization is required. Now just look at the code where we are having one class test object output stream. So first we are writing our data. Where I can write my data, as I already said, you can even write a primitive kind of data, but you can even write object. So for that, here in a try, I've created instance output of a class object output stream, and as I said, it will be having instance of file output stream, and finally I'm having object.dat file. So here in this object.dat file, I'm writing with the use of method write UTF. I'm giving some string. With write double, I'm giving some double score, and finally with the write object, I'm here passing object. Fine. So I am writing actually object type. So here I have created java.util.date class object. Now let me compile and run this code. So when I am running this code test object output stream, at that time simply nothing happens. Why? Because I haven't read that data and it is not shown with the use of system.out.println. So here we can see in this folder one object .dat file has been created. So simply when I'll open this file, it would not be in readable form. You can see some such kind of symbols it is showing because this is your binary file. But here you have created one object.dat file. Now I want to read that file, that is object.date. So for that I'm having another program that is having a class test object input stream, and here it will throw the class not found exception, because if you will not find this object.date, then it will raise this exception. Here in this try, this object input stream is having this instance input. I'm passing and I'm creating an instance file input stream, and inside that I'm having object.date from where I need to read my data. If you remember, here you have written with the method write_utf. So the same code I'll read with the method read_utf. Same way for the double, you have used here write_double. And here I'm reading the same data with the read_double. There I was writing my object. So for that reading the same thing, I'm having java.util.date. I've created the instance, and here I'm doing this explicit casting that will convert into java.util.date, and here I'm reading with the read object, where in your writing of the file you have written write object over here. Fine. So same way I'm reading it, and simply you have read this data, but till that I have to write this in system.out.println. So it will be shown onto a monitor and I can see it. So here I am compiling and running this code, Java object input stream, and here I'll get this output, that John, then 85.5, that is core, and this is the system date and time, right? Now again continue with the theory. The last topic is random access file. Now whatsoever the classes that you have seen in binary IO, they all are the sequential streams. Means you cannot skip any of the data, and you have to read that data into a sequence only. So for this, I would like to give you an example of your tape recorder. If you have used it, then you may know this concept, where there would be a cassette, and when you are playing a cassette side A or B, and once you are playing, it would be read in a sequential form only. Yeah, but there would be a possible thing that you can skip some of the songs or you can rewind it. So you can move forward and backward just like a tape recorder, but it would be a sequential only. You cannot directly randomly read any of the data from the file. And if you want to do it, then we are having random access files. So Java provides the random access file class to allow the data to be read from and written to at any of the location in the file. All of the streams that you have used so far, that is read only and write only streams, and that is why this is known as sequential streams. Java provides the random access file class to allow the data to be read from and written to any of the location in a file. And a file that is opened using a random access file, that class is known as a random access file. So in random access file class, implement the data input and data output interfaces. So basically we are having two interfaces named as data input and data output. When creating a random access file, you can specify one of the two modes. So in C language even, you already know what is mode. Mode means you can give over there a reading access, or you are giving reading and writing access both. So for that you have to specify R or RW. Mode R means the stream is read only, and mode RW means it will allow you both reading and writing. So here you can see these two interfaces, data input and data output. Here you are having two constructors, where in first constructor you can pass a file instance, and in second you are passing it as a string. But here you can see this is the mode in a string that you are giving either it's R or it's RW, anyone. Here you are having close method, get the file pointer means your file pointer is reading right now which byte. So it will return you a byte. Then the length will return a number of bytes in this file. Then reading byte array, reading with particular length. Then you are having a seek method. So here a seek method will actually move your file pointer to a particular position which you have described. Then a set length, then skip the bytes, then you can write the data. So we will use all the methods in our program. So a random access file consists of a sequence of the bytes and a special marker that is called a file pointer that is positioned at one of these bytes. Basically, when you are opening any of the file, by default your file pointer would be at your 0th index, means beginning of the file. Now, for example, if you want to read an integer value using read int method, the JVM read 4 bytes from the file pointer. So before your read integer, for example, your file pointer is at this position, and when you are reading with the read int, it will move forward 4 bytes. As you already know that integer will occupy 4 bytes in Java, and in C language it will occupy 2 bytes. So now directly look at the code. Here I am having one class that is test random access file. Here what I need to do is, first I am having this random access file input object, where I am opening this file with this random access file, new random access file. Here I am giving a name of the file that is inout.date, and here I am specifying the mode of that file. So here I am giving this read and write access both, right? So I can write into this file and I can read from this file. Now here I have done inout, which is my instance object, dot setLength function and 0. What it will do? It will actually clear the file to destroy all the old content if it is exist. But if such kind of file does not exist, then it will simply create a new file, fresh file, right? Now we are writing into the file with this for loop, where I want to write 200 data. So in this for loop I have written I equals to 0, I less than 200, I plus plus. In this I need to write integer. What I need to write? This I. Means first time when I am having I equals to 0, it will write as 0, then next time 1, then 2, then 3, till 199, because I am starting my loop with 0 and it is less than 200. You already know this is integer data. Now I just want to show you the length of the file, current length of the file, without modifying anything, without updating anything. What is the length of this file? Fine. So it will be shown to you. After that, what I need to do, I just retrieve my first number. I'm reading my first data. So I want to move my file pointer to the beginning if it is not right. So I'm simply writing this inout dot seek with this 0 position, means beginning, and I'm writing my first number, that is inout dot read int. So whatsoever will be read from there, that will be printed on your screen because I have written system dot out. Same way, I just want to retrieve the second number. Here the first number, and I'm putting this seek of 0. Why? Because my first number is at the index 0 and my second number will be there on the index 1. So inout.seek 1 multiply by 4. Why we have done this? Because integer will have a size of 4. So if I wish to read my first, means second number, first index, then I need to multiply it with 4. So it will move the file pointer to my second number, and I'll simply show this on my monitor with the use of system.out, and I'll read the data with readInt method. Now I just want to retrieve the 10th number. See, this is not the sequential one. So I just want to read the first, then I second, and directly jump on to the 10th number. So what I simply need to do is, I have to move my file pointer to a particular position. So I want to read my 10th number, so index would be 9 and I'll multiply with 4. So this many bytes I will directly skip and jump my file pointer to this position, right? So from with system.out, I'm showing this on my monitor. Then I'm modifying my 11th number. My cursor or my file pointer is right now on this after 10th number, so I can directly modify my file with this inout.write integer, because I'm having read integer, same way I'm having write integer, and I'm writing this 555. Fine. Then append a new number. So for to reaching at the end, I'm having one method, that is inout.length. So with this length method, I can directly reach to the end of my file. Then I'm writing some content over there, and now I'm printing this, right? Again, now display the new length, because I have updated my record, right? I've written 2 more items into it, and now again I'm showing this what would be the length. Then it will show you again a new length of the file after modifying. Now I'm retrieving a new 11th number which I have written. This I have written, but I haven't read it, I've just write it. So to read it, 11th position means 10th index, and again multiply by 4 with 4. Why? Because integer is having 4 bytes. So I'm moving this file pointer to the 11th number, and simply I'm printing this. So now I'm compiling and running this code, and it will show me this output. That is, my first number is 0, my second number is 1, then directly I have jumped on my 10th number, that is 9. Then my first current file length was 800, but after writing one data, My current length is 804 and the 11th number is 555 and so on. So here we have finished our text IO and binary IO, and in our next session we will see the recursion and the generics. Thank you all.